Recording in progress.
Yeah, cams on everyone. Let's start off. Yeah. So the last thing that we're doing was KTG. We started with this. That's we wrote the ideal gas equation, PV is equal to nRT, and then yeah, we discussed a bit about isobaric, isochoric, and isothermal. Perfect. So let's go ahead. Yeah, today was a busy day actually. I had to take a meeting today for your seniors. Some of them are really panicking. Results are out now. And unka board exams they finished their board exams on like Saturday, most of them. They had just a one exam left on 6th, I guess. So now we are getting almost 10 days break in the middle. आपको भी होगा. If you have taken CS, right? After that PCM, you will get almost 12 days ka break before the computer science exam. So it's too long to wait. So I don't know. Matlab, in the middle, you have all other exams. You have that, right? So that way. In case someone didn't have your dinner or you just reached, right? You can keep your cams off for some time. You can have your dinner, fresh up, and then continue. I know, my fault today. So okay, let's go ahead. You have done this in your chemistry gas loss, so we will not go into too deep into this. We'll directly jump into the things. So we have a PV graph here. This is V naught, and this is 2V naught, and this is P naught, and this is 2P naught, and this point is A, this point is B, this point is C, this point is D. So there, this is your PV graph. It's an ideal gas. Plot pressure versus temperature graph, and plot volume temperature graph. Let's hit this. I'm sure you must have done something like this in your chemistry. How do we draw the graphs for this? Right, Ishwan? Let's see. I'm sure you must have done something like this in your chem. Anyway, so in this, if you can clearly see, AB is your isochoric process, right? And AB and CD are isochoric. AD and BC are isobaric. So first we are trying to draw a PT graph. Now, think about this. In a PT graph, this BC, which I'm marking in green here, and AD, which I'm marking in green here. If you see, they will be same. So I'll just draw two lines like this. This will be BC and this will be AD. The other two ones, AB and CD, are isochoric, and just now we saw in the previous class, in an isobaric process, right? In a PT graph, will be a line passing through the origin. So there are two isochoric processes, so we need two lines passing through the origin. And who has more volume? So in isobaric process, whoever has more volume will have less slope. In isochoric process, P is equal to NR by V into T. Slope is proportional to 1 by V. So this guy is CD and this guy is AB. There, done. So now this point is an intersection of AB and AD. So this is A, this is B, this is C, and this is D. So just draw a new one. There, this is how the graph looks, everyone. It's not a parallelogram, it's trapezium, and those two lines will actually pass through the origin. This is A, B, C, and D. Check. All got the idea what we did? Using the same logic, can you draw for the VT graph? Try, I'll give you a minute. It would look kind of similar. This is your PT graph. Can you draw the VT graph? Anyone confused with this graph? Like, how did I get the curve like this? Why is it at an incline? Anything you're not clear, please ask. Get me the VT graph. How did you get raised? Otherwise, see na BC and AD are what? They're horizontal lines, same pressure. On the y-axis, you have pressure. So how does an isobaric process look like? A constant pressure. How does a constant pressure look like? A horizontal line, isn't it?
Yes, sir.
Sure, no? In a PT graph, if I ask you a constant pressure means what? It looks like this.
Yes, yes.
So how does a VT graph look like here? The graph, when you look, it looks the same. So here, VT ka thing will be two horizontal lines. Now be careful here. The one with the higher volume is CD, so that is up, and then this is AB. So this is isochoric process, and then we have BC, this one and this one. The one with the higher pressure will have lesser slope, so this guy is BC and this guy is AD. Now, the only thing you have to be careful here is it looks the same, but if you observe, the direction has reversed. So exam there will be two options. The graph will look same, but ABCD will be clockwise or anti-clockwise. Here it is going anti-clockwise. So that will be a difference in the option. So be careful with that orientation. So there'll be two options with ABCD, clockwise, anti-clockwise, and you'll get confused. All got this thing? Same thing. Let me ask you one more like this. Let's say it is a TV graph. This is 2T naught and this is T naught. Just draw PV graph. I gave you temperature versus volume graph. I want you to draw a pressure versus volume graph. Let's see how you do this thing. Let's see. You're drawing a PV graph. So the volumes are two straight lines. Okay. This is your AB and this is your CD. How does a constant temperature graph look like? They are actually isotherms, isn't it? So they'll be hyperbolas like this. Which one is the bigger one? The higher the temperature, the farther the isotherm. So this is BC and this is your AD. Then I can just erase this extra lines. That is how it would look. So this point is A, B, C, and D. Easy? All clear with this? Sudiksha, Samyak, Shriyan, Tanishka. Clear? Yashvi? Great. Next one. So if you see, we are just playing with the PV is equal to nRT, which you have done in your chem. Same thing. We are seeing few models of that, but then I'll show you physics how they'll actually frame. So we have a PV graph here. PV naught, P naught, 2p naught. This is a B, C, and this is how the process is going on. It is n moles of ideal gas. So the first question, how does the temperature vary on AB, on BC, on CA? So this is a theoretical question. Options will be like this. Temperature will always increase, temperature will always decrease, temperature will increase and decrease, temperature will decrease and increase, temperature remains constant. These are options they will make up. Find the maximum temperature in the process ABCA. So when you go from A, B, C, and back to A, at some point you'll get maximum temperature. What is that maximum temperature in the whole process? The second one is the actual question. The first one is still fine, a decent theoretical one. So the first question is, how does the temperature vary when you go from A to B? Options will be, it is always increases, always decreases, increases and decreases, decreases and increases, remains constant as options. First part is right, Ishman. Get the temperature, everyone. Let's see how will you first figure out about the temperatures, because it's important. They might give you a graph like this. They might say you have a curve like this, and they can ask you how does the temperature vary on this AB curve. So then you should know how will you handle for that. Think for a minute, then I'll show you the first part, and then I'll give you a little more time for the second one. Nee, Param, your B part is wrong. Samyak, you're going from C to A. A to C nahi hai. Yeah. Get me the other, na? A, B, and B, C also. B to C is the most important one. नहीं समझा. B to C you messed up. If it is the exam, I'll ask you how does the temperature vary in B to C. Let's see. So on a PV graph, whenever you're talking about temperatures, so this is what you do. First ask yourself, on a PV graph, how do you look at temperatures? These are not straight lines. So on a PV graph, the temperatures are this hyperbolas. Where would be actually going like this? Something like this. You're getting it? I'm not drawing it properly, but you got the point. And the farther the isotherm, the higher the temperature. So you do the same thing here. So on this triangle, draw your isotherm. So I will draw an isotherm which is just passing through A like this. Then I'll take one more isotherm going like this. Then I'll take one more isotherm going like this. Then I'll take one more isotherm which is, there is one isotherm which is going through B and C, because B and C, they don't have same temperature, sorry. Something like this. And then if you keep drawing, you will find you will get one isotherm where this line BC will just become a tangent. Isn't this how it goes? If you just keep drawing more and more and more isotherms, again, they don't look like hyperbolas, but if I just keep drawing them, you will notice, I'll just name them, okay? I'll call this thing as 1, 2, 3, 4, 5, and 6. Now look at the points here. So if you look at the points on BC, you're going from higher isotherms. So AB, you're going from 1, 2, 3, 4, temperature increases. That's it. That is how you figure out. Doesn't matter what kind of curve I give, you'll just put some isotherms and you will see, are you climbing higher isotherms? Are you coming down the isotherms? So temperature increases. But when you look at the BC, you can clearly see the points here. This was the triangle isotherm 4, this is isotherm 5, this is isotherm 6, again 5 and again 4. So when you go from B to C, you are going from 4 to 6, right? And then you're going from 6 to 4. So temperature first increases and then decreases. And this will also tell you something. So in this entire process, which point has the highest temperature? 0.6, isn't it? So the process BC will contain the maximum temperature. We need to find that. When you're going from C to A, you can clearly see again you're going from 3 to 1. You're going the lower isotherms. Is this making sense, everyone? That is how theoretically you can figure out by seeing a graph whether the temperature is increasing or decreasing. Any doubts on the first part? Get the second part. So if this is the process, now we know on BC there is a maximum temperature somewhere. Now, luckily, if it's the mains question, you know what they will do? They will give you this as 2V0. Now, can you see the graph? By symmetry, can you argue the point must be the midpoint? 3V0 by 2 and 3P0 by 2, and then you will say maximum temperature is that. That would have been actually made your life easy if it was symmetry. But unfortunately, it is not symmetrical. That is 3V0. So if it is a mains question, they'll give you symmetry, 2P0, P0, and V0 and 2V0. Now, can you find the maximum temperature in the process? Think, how will you do that? I'll give you a minute, give it a try. Then I'll tell you how to do. Anyone not clear with the first part, please ask. So yeah, there is actually no way to do it. We have to use maximum minima. So can you find the equation of the line BC? Can you find the equation of the line BC? So you can take the coordinates. What is this coordinate? X ka place may we have V and Y ka place may we have P. So this coordinate is 3V0, P0. And this coordinate is V0, 2P0. So using this as your X and Y axis, try to get the equation for the line BC. I hope you know the line equation. Y minus Y1 is equal to Y2 minus Y1 by X2 minus X1 minus X minus. Just use that. So X and Y ka place we have P0 and this thing. Right, Samyak, you got it. Just get the line. Samyak, can we also try like this? Like, since we know the line BC is a tangent to an isotherm where PV is equal to constant. So slope of this must be slope of BC. Think, can we do something like that? Will that be easy or will it still lengthy only? Think from that perspective. Others, give it a try. Get the equation. Just give me a minute. How do we get the equation? So see. So y minus y1. So I'll take v naught and 2p naught as x1, y1. This is your x2, y2. So y minus y1. So that is p minus 2p naught is equal to y2 minus y1. That is p naught minus 2p naught by x2 minus x1. That is 3v naught minus v naught by v minus v naught. So from here we will get that will be minus p naught by 2v naught, v minus v naught plus 2p naught. This is your one equation. And we also know ideal gas equation PV is equal to nRT. Take this thing, substitute here. You end up with P naught V square by 2V naught plus P naught V naught V by whole by 1 by nR is equal to T. So that is your temperature as function of volume. So maxima minima. For max temperature, dt by dV is equal to 0. So then you end up with minus 2P naught V by 2V naught plus P naught V naught is equal to 0. Oh, I think I messed up something. I messed up something. There is a plus P naught also sitting now. That would give you 3. Wait. This is P naught V naught by 2. That will give you 5 by 2. So yeah, so you'll get a V is equal to 5 V naught by 2. There. So at this volume, you get maximum temperature. Then you'll take this and substitute here. And when you do that, you will end up with T max is equal to 25 P naught V naught by 8 LR. Here, it becomes more of a max question, isn't it? There's nothing in physics that PV is equal to nRT is the only physics there. Everything else is max. I literally asked you to find the point with the maximum product of PV. So it's like there is a straight line, and this is a relation between x and y. Find the maximum value of x into y. It has become a maximum minimum question. All clear with this? But like I said, there is another way you can think of. For different isotherms, when the line BC becomes a tangent, so slope of the tangent at that point, I think you'll still have to do this much work only. It will not be that easy because you will start with PV is equal to constant assumption. Then this slope of this must be slope of this line. Then you will get something as a, you have to figure out there are multiple things. So I think you'll still have to put the same amount of work. But yeah, that is a one way to think. हाँ Samir.
सर वो स्लोप इक्वेट कर ले फिर उसके बाद वापस पर वो लेवल जो है ना हाइपरबोला का तो वो निकालने के लिए
Yeah.
वर्किंग
I think वापस तुझे PV is equal to NIT तो वापस यूज करना ही पड़ेगा ना, वो भी रिलेशन. So PV is equal to constant. I think वापस ऐसा ही आएगा कुछ. I think tension will be temperature is equal to something in terms of volume, and then again maximum minimum करना पड़ेगा, I guess. Right? So actually, it's not becoming anything easy. Yeah. All clear with this? So these are questions, which you must also have done in chemistry. These are just based on equations. But generally, physics may they don't ask, they do ask at mains level, but yeah. But this can also be in the chemistry thing. So let's see something more related to physics. You can mix up some mechanics. Let's start with something easy and then we'll slowly bump it up. So we have a container, we have a spring, and we have a piston. The spring constant is K. Here, this is vacuum. Here we have a small gap, very small gap. Then what you did, you introduced some gas into that gap, right? So that's a small gap. That is also vacuum only. There is nothing there. System is in equilibrium. Then you went and introduced some air, some gas into this gap, whose temperature is T naught, and this thing went up by a height h. Remember, this thing is still vacuum. The gas is introduced and the piston goes up by h. Then what you did, you kept the gas as it is, but you double the temperature of the gas. Somehow you gave some heat to the gas and you increase the temperature. When the temperature of the gas doubles, the height becomes h dash. Keeping all other things like, the number of moles is same. You're not messing up with the amount of gas. If the temperature of the gas is doubled, height becomes h dash. Find h dash. It moves from h. So h is already given, that you know. So you have to report the answer in terms of h. I hope the question was clear. So initially you have a piston. Does the piston have mass? I don't know. Does the spring is in natural length? We don't know. Nothing is given. So when nothing is given, generally it is better you assume the piston has some mass. And generally, if they don't give you anything, means it really won't matter also. But anyways, now when you introduce some gas into that gap, the piston moved up by height h. Now, if you double the temperature of the gas without changing the number of moles, the height becomes h dash. Find h dash. This is an ideal gas. So in the question, if you see, right, there are two words which you should be very clear. One is equilibrium, one is ideal gas. Equilibrium means which chapter? NLM means what should I do? Draw an FBD. Ideal gas means what? KTG, which equation? PV is equal to nRT. That's it. You just only know these two things. Play around with that.
Sir, the first diagram, it is supposed to be natural length, right?
No,
Sir,
nothing is given.
the very first
You
one.
are sleeping. I already talked about it. There is no information about it. You can assume natural length. You can, maybe it is elongated. We don't know.
Okay, sir.
If the piston has mass, why will it be in natural length? We have one answer. Hope you got it. Others get it. Right, Samit. We have two answers. Let's see. Now, does the initially spring in natural length? We have no idea, like I said. So let's assume the spring is not a natural length and the piston has some mass. So let's start with that FBD. So let this be K into X and let this be mg. Since it is an equilibrium, Kx is equal to mg. Next thing. Now when you introduce the gas it must be some pressure, let it call it P1. Now when you draw the FBD, the spring of force must have become K into X minus H. Remember, if X is your initial elongation, right now it would be X minus H. And your own weight mg and the atmosphere pressure, not atmosphere, gas ka pressure P1 into area. Since this is also an equilibrium, you can clearly see P1 into A is equal to K into H. Kx and mg will cancel. Same thing when you draw the FBD for this guy, the spring force will become K into X minus H dash. This will be mg. So basically that Kx and mg will always cancel. So it's even if you had assumed it is massless, it would have worked out for you. So you will get here P2 into A is equal to K into H dash. You're done. Since it is an ideal gas equation and the number of moles are same, I can use P1 V1 by T1 is equal to P2 V2 by T2. So initial pressure is P1, which is KH by area. Volume is simply A into H by temperature is T0. P2 is K into H dash by area. V2 is area of cross section, not given. We don't need it anyway. H dash by temperature to T0. You can clearly see we'll get H dash is equal to root 2H. Clear this? Easy? Let's see one more. Let's do a little tougher one. There, if you see, we just did one equilibrium and one ideal gas equation. We have an insulated container. It is also called as adiabatic container. So adiabatic container does not mean adiabatic process. It simply means the heat cannot escape through the walls. So they will say sometimes adiabatic container. So don't get confused as adiabatic process. Adiabatic walls, adiabatic pistons, or something like that. So we got a spring between two pistons. So this region in the middle is vacuum. This whole left-hand side compartment is filled with gas. Temperature is, this is 1 mole gas. 300 Kelvin. This is also filled with everything. 300 Kelvin. This length is 1 meter. This length is 1 meter. What is the length of the middle compartment? We don't know. Initially, the spring is compressed by 1 meter. So spring is not a natural length, obviously, because the left and right side you are pushing, the spring has to be compressed. Be careful. Spring is compressed by 1 meter. This length is not 1 meter. Right? Pistons are smooth and massless. Smooth, insulated, and massless. Now what we did, the same compartment, you gave some heat to the gases and they change the temperature. This compartment ka temperature became 400 Kelvin. This compartment ka temperature became 500 Kelvin. So temperatures have become different. Maybe you gave heat from outside. So temperature on the left and the right container becomes 400 and 500. Find the new compression in the spring. Now, when you change the temperature, pressure changes. Something happens and the spring will get compressed. Remember, this gap is still vacuum only. Find the final compression in the spring. Initially, it is 1 meter compressed. Let's see. This, more than saying it is a tough one, it is a lengthy one. Try. I'll give 3-4 minutes. Let's see how you handle this. Again, you can clearly see it is an equilibrium. So initially, finally, you're in equilibrium. So equilibrium and ideal gas. There are only two equations you can write. Let's see whether you got the equation right. So start with the free body diagram. That is the most important thing. If you got the equations, then yeah, calculations are a little lengthy, but not, it's not like something very difficult. It's still doable. Okay, so let's see for the thing. Now, if you just look at any one piston here, the left one, we have a spring force, which is K into 1, and we have the gas, which is pushing. So I will assume initially the pressure is P1. This is also P1 by, if the pressure is not same on both the sides, the middle compartment will keep moving. So it has to be same. So this is P1 into A. So this is your one equation. P1 into A is equal to K. This is equation 1. Perfect. And what about the ideal gas equation? P1 into A into 1 PV is equal to number of moles is 1 into R and temperature is 300. So P1A is equal to 300 R. This is your equation 2. I got it from PV is equal to nRT. No, Shriyansh, that is wrong. No, Shaurya, that is wrong. Now, for this guy, when I write this thing again, here also I can argue the pressure here is P2, the pressure here is also P2. Why? If the pressure is not same in both the compartments, then the middle compartment, if you see the net force acting on it, will be P2A and P3A, and the piston will keep moving. So pressure has to be same on both the compartments. Clear with this? And in this process, let the left compartment expand by x1. So the 1 meter becomes 1 plus x1. Let the right compartment expand by x2. So this becomes 1 plus x2. Let's compartments expand by x1 and x2. So what is a new compression in the spring? So initially you're already compressed by 1 meter. Now you're compressed further by x1 and x2. So new compression is 1 plus x1 plus x2. So for convenience, I'll just call it as x. So let x1 plus x2 be equal to x. Perfect. So draw the FBD of any one piston. The spring is pushing with K into, initially compression is 1, now the compression is x. And here the pressure is P2 into area. So we get P2 into area is equal to K into 1 plus x. This is your equation 3. And then what about the ideal gas equation now? Remember, the gas ka temperature changed on both the compartments. So we'll get two equations there. So I'll write it on the next page maybe. For the left compartment, what remains constant? Number of moles. So I'll use the equation P1 V1, or I can just directly use this thing. What is the pressure? P2, area, length becomes 1 plus x1 is equal to 1 R, temperature is 400. That's your equation 4. For the right compartment, pressure is same, P2 into area 1 plus x2. Number of moles is 1 R, and the temperature is 500. There, everyone. 5 equations, 5 ones. Please check your equations. If you got the equations, then now it is just a matter of solving. So initially, since both the gases are identical, you'll get one gas equation. Finally, you'll get two gas equations, and you'll get two equilibrium equations. Please have a look at the free body diagrams and have the look at the equations. Can you simplify this? I'll give you a minute. Anyone not clear with the equations, please ask me. All clear with the equations? So let me just put on the equations again in the next page. So P1A is equal to K. That was your equation 1. P1A is also 300 R. So basically I can eliminate P1A. So I got the spring constant actually. Equation 3. P2A 1 plus x. P2A is K into 1 plus x. P2A is 1 plus x1, 400 R. P2A into 1 plus x2 is 500 R. And remember, we have taken x1 plus x2 is equal to x. Perfect. So add 4 and 5. Because when I do that, I'll get x1 plus x2 there. So that will be p2a 1 plus 1, 2 plus x1 plus x2 is x is equal to 900r. And what is p2a? Take this and substitute here. That would be k into 1 plus x into 2 plus x is equal to 900r. But what is k? Take k from here and substitute here. That would be 300r. That would be 2 plus x square plus 3x is equal to 900r. So we get x square plus 3x plus 2, that will be minus 1 is equal to 0. We got a quadratic. So get the roots for this. So x will be minus 3 plus or minus root over b square 9 plus 4 by 2. Minus 3 plus root 13 by 2. This is not the answer. Be careful. X is this. What is the final compression? 1 plus x. X is the additional compression. That would be root 13 minus 1 by 2. There, have a look at this. Got this? The equations are not tough, right? You just have to write equilibrium and the gas equations. Yeah, solving is a little lengthy, but yeah, it is doable. It's really not that out of the world. Please have a look at the equations. This is how they'll frame questions in the exam. So they will mix up physics like this. Let's see one more. Any doubts on this? Clear now, Vanshika? Trishi? Sure. Param? Advai? Advai, clear? Pratyasha? Shreyansh? Great. This next one is actually a question from Herodo. Let's get this. Just read the question. Take a minute, then I'll explain you the question, then I'll give you 2 to 3 minutes more. Hope you read the question. So if you see in the question, right, there are a few data points here. This was actually a cylinder. Huh? Picture looks like this. So we have 2 pistons here. The ones I'm marking in red, these are the pistons. What is the area of the piston? I don't know, right? But let's say if the area is A1, mass is M1. They didn't give you this. Similarly, this mass is M2, and this area is A2. But what they gave instead, the cross-sectional area of the upper piston is 10 centimeters square greater than the lower one. So this information is given. So what he indirectly gave you is A1 minus A2 is delta S. And the combined mass of the two pistons is 5 kg. So he didn't give you M1 and M2, but he gave you M1 plus M2. That is your small m. Outside pressure is 1 atm and you have some gas trapped between them and there is a string between them. This is a string. So now the question is, if you change the temperature of the gas, so what is the initial temperature of the gas? Not given. So he's simply asking by how many kelvins must the gas ka temperature be changed so that this whole system will shift by 5 centimeters. So if you somehow give heat to the gas in the middle and the temperature rises by something, this whole setup will just go up. Now you need to ask yourself, why the hell are you going up and how is the relation between them? Think. I'll give 2-3 minutes.
So assume 1 atm and 10 raised to 5 Pascal.
Assume kar lena.
Okay.
It won't matter. It would matter. We'll take 10 power 5 only. Now what will you take? SI units तो वही है. You want to use your chemistry क्या thing?
हाँ सर
Don't.
केमिस्ट्री में 101.
पागल हो जाओगे then because RB लेना पड़ेगा ना then in terms of that only liter, ATM and all that stuff. Physics always SI units. Let's get this. Let's see. 0.9 Kelvin. Now exactly I don't know the number, but let's see the equations. First, let's try to one thing understand. See, initially the system is at rest. Agreed? The moment you say that word, the system is at rest, you know it is an equilibrium. You have to draw an FBD. That's what I'm saying. When you don't know most of the times what to do or what the hell is happening, always start with an FBD. That I have seen, when you just draw an FBD, things will start, you'll seeing things. You'll start seeing things. So if I draw the free body diagram, so atmosphere is pushing from outside, P naught into A1. This would be your tension. This would be your weight, M1G. And the gas is also pushing up. So that will be P gas into A1. This will be tension. This will be M2G. This is P naught into A2, and this is P gas into A2. Check. Those are all the forces you have. And you can clearly see here P gas, A1 minus A2 minus P naught, A1 minus A2 is equal to mg. You end up with P gas will be P naught plus capital Mg by delta S. Did you notice something? This is constant, meaning even if the piston goes up, piston goes down, it doesn't matter how much it moves, right? P naught is not going to change, mass is not going to change, the area is not going to change. It does not depend on the distance between them. Sudiksha. Got something? No. Okay. So what kind of process is this? Now tell me, no matter what you do, the pressure will never change. This is an isobaric process. So that is the first thing when you draw an FBD, you will realize no matter how much the piston moves, the pressure of the gas will never change. Is that clear, everyone? Once you know the pressure of the gas does not change, now we know ideal gas equation PV is equal to nRT, right? I can differentiate on both sides. This will be PdV plus VdP is equal to nRT. Since pressure is constant, this term will be 0. So you end up with P gas into change in volume is equal to nR into change in temperature. That's what I'm asking you, change in temperature. So I know pressure of the gas. So if I can find the change in volume, my job is done. Now if you look at the system there, this was the piston here and this was the piston here. Now from this position, let's say this thing has gone up by, he said that how much also? 5 centimeters. So this thing has traveled by L and this thing also has traveled by L. So the additional volume will be the shaded area. So the change in volume, that A1, because of A1, the volume increased, A1 into L. Because of A2, the volume decreased, which is A2 into L. So this will be, again, A1 minus A2 is delta S into L. That's your change in volume. So every time this thing moves by distance L, right, the A1 will increase the volume by A1L, whereas A2 will decrease the volume by A2L. You end up with L into delta S. Yeah, you got everything. So pressure of the gas will be P naught plus mg by delta S. Change in volume is L into delta S. Number of moles are given. 1 mole of gas is given. And Arca value you know, and temperature you know. So solve this, you'll get the temperature. I will leave the solving to you. 7583, okay.
So it should be delta T, right?
Delta T.
So
So
15
keep
R
like
by 2.
this. 15 R by 15 by 2 R.
15 by 2 R, sorry.
R is 8.314 or 25 by 3. Please have a look at the equations. Equations are clear, everyone? I hope you can see the difference, right? Chemistry mein, you must not have done something like this. So here, if you see, we bring a lot of, that equilibrium problems and all that stuff here. That would be the difference. Clear. Take a break. Come back in 5 minutes. We'll continue from here. I will wrap up early also today a little bit. Come back in 5 minutes. We'll have a very small break.
सर
हाँ
सर हमने क्या किया 8 से लेके 8:30 तक?
कुछ नहीं, वो पीवी इज गोल्ड एनआरटी दैट ओनली वी आर प्लेइंग अराउंड.
ओके सर.
बस ये ग्राफ्स किया था हमने. पीवी ग्राफ इज गिवन, ड्रॉप ईटी ग्राफ, टीवी ग्राफ, फाइंड मैक्सिमम टेम्परेचर. यू विल अंडरस्टैंड.
ओके
एक बार
सर.
नोट्स देख लो,
सर
इतना
वो
कुछ नहीं है.
मतलब प्रोसेसेस के बारे में हमने ज्यादा नहीं किया ना.
नहीं नहीं नहीं, वो तो थर्मोडायनामिक्स है ना, केटीजी में नहीं आएगा.
ओके सर.
दैट इज नेक्स्ट चैप्टर. Sure, let's start off. Next thing. Now, in kinetic theory of gases, right, there is a derivation of this PV is equal to nRT, which is actually important for boards, but we don't have it for JEE. के लिए इतना नहीं है. So we will skip the derivation, but the assumptions are important. So when we derive that PV is equal to nRT equation, it is derived under a certain assumption. So what are those? The first thing, a gas consists of large number of molecules. Now, when you say large number molecules, we are talking about an Avogadro number. Other scans on Na, which is 6 into 10 power 23, which have negligible volume. So we are treating the molecules as point masses. Now, why do you need to have a large sample? Now, this is important because if your sample has very less number of molecules, tell me one thing. When you switch on your room, in your room and you switch off your AC, right, and the AC shows 24 degrees, does it mean the moment you switch on the AC, suddenly the whole room ka temperature became 24? Every part of the room will have different temperature, isn't it? So if every part of the room has different temperature, can you still say the temperature of the room is 24 degrees? So same way, when you say the temperature of a gas or the density or a pressure of a gas, what you're meaning is every point on the gas, or if you take any small region, should be identical. The gas can be assumed to be homogeneous, basically uniform. Imagine you have only like 1 lakh molecules. Most of the space would be empty. That is pressure, temperature, and density are same at every point. Now, this thing, right, you need to understand. When you have a large sample, right, suddenly the whole system will start behaving like some kind of a symmetry. For example, again, example, see, just a thing. Let's say if you have a rod. So about the midpoint, the left and right will look identical, isn't it? But imagine if you take an infinite rod, every point on the rod is a midpoint. Do you agree? When you have an infinite rod, every point can be treated as a center point. It is symmetrical about the left and right is always symmetrical. So when you have a large sample, right, things which look like, won't happen will keep happening with a lot of probability. For example, see, if I ask you this question, now in our class, how many people are there with the name Arun? I'm there, one, right? But if I ask you, like, what is the probability of finding two Aruns in such a small group of 2025? Zero. But if I ask you how many people are there with the name Arun in Mumbai, I'm sure you'll find thousands. What if I ask you this? How many people are there in Mumbai with the name Arun and who teach physics? I'm sure you'll still find 10 people or 14 people. Let me make it more specific. How many people are there with the name Arun, who is from Andhra Pradesh, who did his IIT Madras mein electrical BTech and then teaching physics for J? Now, if you put so many conditions, what do you think is the probability of finding someone like that in Mumbai? Almost zero. What about all over the country? India? Maybe still zero, but I know there is one person in Pune. His name is also Arun. He's my batchmate. Right? We both studied together in 11th and 12th in Andhra Pradesh. My name is Arun Kumar Sana. That is my full name. That guy ka name is Arun Kumar Sahu. बस वो last two different digits difference था. My roll number is EE06B006. IIT में this is how they give roll numbers. EE means electrical engineering, 06 meaning 2006 batch, B means BTech, 006 is the roll number. That one number will tell all the information about you. His roll number is 005. Right? We studied 11th and 12th together in the same institute. Right? After that, he is also a physics teacher now. In Pune, he is working on his own. So, yeah. So, see, things, right, which is not supposed to happen, you will actually start seeing. When you have a large sample, things will start happening. I'll give you one more example. Let's say you have a flight to, at 4 o'clock in the morning. Right? What do you do if you want to go reach the airport by 1 o'clock or 2 o'clock? What do you do? How do you travel to the airport? You just open your app, Uber or Ola, book a cab and go, right? Can you just tell me, like, night 2 o'clock, how can you expect a cab driver to be there in your street and waiting for you to pick up? What is the probability, seriously? But you don't even think twice, isn't it? You're damn sure you'll get a cab at 2 o'clock in the night. But if you go to year 2015, right, 14, that time when there was no Uber, right, and when we had to travel in airport, right, sometimes the flight was early morning, 6 o'clock ka flight tha. I still remember. And you have to reach the airport by 4:30. So I have to catch a cab at 4 o'clock or 3:35, 3:50. Problem is, there was no Uber, there was no Ola. There used to be something called Meru cabs. Kabhi suna? There is something called Meru cabs karke. One of the most hopeless service. Right? When you book a cab, you'll never get a cab for sure. They will always cancel the cab exactly 20 minutes before, meaning you have to book it one day before, and after booking 20 minutes before, they'll cancel it for you. They'll call you and tell you, sorry, we couldn't find a cab. So the only way we could travel, right, is one day before we used to go to the auto stand, right, and we used to talk to an auto person there, boss, early morning I need to catch a flight at 4 o'clock, so can you come and pick me up at 3:30? And they used to charge 500 rupees. Right, this is in 2015, 10, 11 years back, 500 rupees was huge. Matlab, if you actually take an auto and meter and go, it will cost you like 90, 95 rupees, 100 rupees max. But because early morning he's coming for you and he has to come back alone, he used to charge 500 rupees and there was no other option. So getting a cab was, forget about it, it was next to impossible. But for you guys, it looks so common. So when Uber and Ola came into the market, they had a big problem. This is a problem for any company. The customer says, there is no cab, so why should I use your app? The cab driver says, there are no customers, so why should I install your app? Can you see the problem? If there are customers, cab drivers will register on the platform. The customer says, there are no cabs, so why should I install your this thing? So Uber did something. It said, you register on my platform. For every 7 rides that you take, you can keep all the money, plus I'll give you 2,000 rupees bonus. If you do 14 rides, keep all the money, plus I'll give you 4,000 rupees bonus. And the cab drivers were quite interested. Matlab, 7 rides, there is no commission, nothing, and plus you're getting 2,000 rupees just like that. I think you were still kids then. Uber, initially, right, when you install the app, you get 3 rides free. You can just book a ride and you can go anywhere you want, 3 rides free. People literally used to change the SIM, After doing the 3 rides, you used to change the SIM and get again 3 more rides for free. So people used to do all that stuff. So anyway, so game went on like that and Uber drivers were earning a lot. There were some people were earning 1.5 lakh plus per month. This was in 2015 and 16. Meaning there was a joke, not a joke. Actually, this was there. In Bangalore, right, the software people go from the office to the company, right, in a cab. The salary of the 3 people who are sitting, the software engineers, is combined less than the driver. So something happened in Bangalore. People started leaving jobs and started becoming cab drivers because it was profitable. And it became a very good job at some point. Like people were just earning in lakhs in Uber and Ola. So an estimated, in Mumbai at some point, the peak value around 150,000 people are driving cabs in Mumbai and surrounding region, Pune and everything combined. Can you just think of that number, 150,000 cabs? Everyone is a cab driver. And Uber started losing hell lot of money and then stopped the incentive. That is when things, messed up. I think now the number is less, like 20, 25, 30,000, I guess. So, but think about it still. If you have still 25,000 cabs all over Mumbai, do you think all the cabs will sit in Bandra? You don't get so much business, right? So the cabs have to get distributed. So eventually, again, the same thing. Because you have so many cabs, you can be sure the cabs are uniformly distributed to a bit. So you will find one cab in your some corner of your street, even at morning 2 o'clock. If you had only 500 cabs or 1,000 cabs in Mumbai, all the 1,000 cabs will be near airport because that's the best place to get business. But if you have 30,000 cabs, so you don't have so much business in the airport, some cabs will understand, boss, this is pointless to be at the airport, let's be at somewhere else. So they will start spreading out. So this is also called as, law of large numbers. When you have a large sample, things which are not supposed to happen will start happening with a lot of frequency. And it looks quite normal. So anyway, meaning if I had to give an example, right, I say like this. Let's say if you just do only 10 questions, nothing happens. When you do 100 questions, nothing happens. When you do 1,000 questions, you might feel like, okay, something, it is clicking. It will start understanding things. But the moment you hit 10,000 questions, suddenly everything falls in place. You will see a question and you'll start understanding, okay, this is what I have to do. You actually start gaining some kind of an, we call godly powers. You see a question and it clicks. The only difference between you and me, right? You know what? I had enough time to do more than 2 lakh questions over my span. Right? Over the last 15, 16 years of teaching, I must have solved more than 2 to 3 lakh questions. So when I see a question, right, you guys are thinking still what to do. For me, for some reason, I see a question and I know what to do. And it happens so fast. For me, it feels like magic. I said, like, what the hell did I think actually? The connections just fire up. Now, that happens because you did a huge sample. And that's what I keep telling you. If you're not solving enough questions, you will never reach that state. So that is one sec. Anyways, so that is one important thing. So in a gas, when you have a large sample, you can assume the gas trace to be uniform. So example, if I ask you this question, let's say if you have a container and it's a 1 meter cube container, and let's say we have only 10,000 molecules. And if I ask you this question, if you double the number of molecules, what happens to the temperature? Or what happens to the pressure? How will you answer this? Now, if you try to use the ideal gas equation, PV is equal to nRT, right? That will say P is proportional to N and the pressure should double. But the problem here is the equation PV is equal to nRT is not valid. 10,000 molecules is such a small sample. Most of the space is actually empty. So pressure and temperature are undefined. That is, PV is equal to nRT is not valid. So there, just be careful with that. If your samples are very small, you can't use this ideal gas equation. That is valid only when you have a large sample. Since the number of molecules are small, most of the space is empty. You won't even find a molecule there, so nothing looks uniform. The second point, the molecules do not have any preferred direction. See, for them, they don't know what is X and Y, Z axis. For them, everything is same. And this leads to some really important things. Let me ask you a question like this. Let's say in front of your house, the road you have, if you see 2 red cars going in one direction, can you say there'll be 2 red cars going on the left side? How true is that statement? Looks completely faulty, right? But evening, 5:30 or 6 o'clock, Western Expressway, complete traffic loaded on both the sides. Can I say for every 2 red cars going on one side, there will be 2 red cars going on the other side? There is a high chance it might actually happen. Why? Simple reason. The amount of traffic is so huge, it is very easy to find red cars, and there is a high chance the cars are actually going in both the directions. So again, that's what I'm saying. When your numbers are large, things will start actually happening, which looks like impossible normally. So the motion is random. They just go in all random directions. Now, because the direction is random, the average displacement is 0. And therefore, your average velocity is 0. Third, the collision between the molecules and the walls of the container is perfectly elastic. Right? In ideal gas, there is no interaction between the molecules except during collision. So in an ideal gas, right, if there are two molecules, there is no van der Waals force between them. Only during collision, you can say there is a small repulsion between the nucleuses and they just bounce off. Other than that, we assume there is no other interaction. Now, because of this, since there is no interaction between the molecules, you cannot liquefy an ideal gas. You must have done this in your chemistry. An ideal gas cannot be liquefied. That is one of the reasons why helium and hydrogen are so difficult to liquefy. So they can ask a question like this thing, huh? This you must have seen in chemistry. For a real gas to behave as an ideal gas, should it have low temperature or high temperature? Should it have low pressure or high pressure? Tell me that. For a real gas to behave as an ideal gas, should it have low temperature or high temperature? Should it have high pressure or low pressure? Hmm. Right, Samyak. Right. It should have high temperature. Why high temperature? If the molecules are moving really fast, you're not giving enough time for interaction. And low pressure, the molecules will be far apart, so we can ignore the interactions between them. This is how you'll get theoretical questions, everyone. Molecules obey Newton's laws of motion and are unaffected by gravity. Molecules move in straight lines. The time interval between collisions is negligible. So the reason they change direction is because of collisions. So using all these things, right, we have a bit of a derivation there from which we get PV is equal to nRT. We'll not get into that. Right now, if you look at the velocities, right, we have a problem there. Since your average velocity is 0, we have no information about the velocity. But then we have something called Maxwell distribution of speeds. So you have done all this in chemistry, I suppose. So we'll not go too deep into this. So if you try to plot the graph, NV versus V. So here NV is nothing but dN by dV. That is a number of molecules at a given speed. And just to give an example, let's say we have 100 molecules. Between 2.1 meter per second and between 2 meter per second. So the quantity delta N by delta V will be 100 by 0.1 or 1000 molecules per meter per second. So in that small velocity range, you have 100 molecules in 0.1 meter per second ka range. So that is the meaning of dN by dV there. So when you plot this graph, so think of like this. How many molecules are there with zero speed? Almost zero. So there will be very few molecules with less speed. You will get a bulge here. This is also called as a normal distribution. And then it becomes like this. So you get a bulge and then this actually you'll notice for all samples. If you try to plot your board ka marks versus the number of students. Tell me one thing. Let's say, I don't know how many marks is for your board. I think it's for 500, right? In your 10 standard boards. How many students are there who will score 0 marks? Negligible. How many students you think will get less than 100 marks? Will be there, but that also will be very less. How many students are there with a scores of range around 400 and 350 and 450 current? You will find a lot of bulk. How many people are there with a score of 490 and more? Again, very small. When you actually plot all these things, you'll actually observe this is the distribution. Same thing. If you look at the height of all the adults between 18 to 30, you will find most of them people, right? How many people are there who is an adult more than 18 with a height of 0 feet, 1 feet, 2 feet, 3 feet? You might exist some dwarfs, but if you see most of them, right, are in a range of something like 5 to 6 ka beech mein, you'll find a most bulk. Right. And again, how many people are there with a height of more than 7 feet? You might find 1 or 2 exceptions. So this is called normal distribution. You will see this everywhere whenever there's a large sample. If you look at the salaries of the people, if you look at the marks of the students, if you look at the height of the people, you take anything, you will see most of them will follow this distribution. So based on this, someone actually figured out CBSE is goofing up. So what this guy did, something happened before COVID, okay? He took out all the data from 2010 to 2016 or 17 CBSE ka marks, and he actually started putting on a Gaussian distribution. And what this guy found, this graph, right? Normally you should get the distribution close to the center. The distribution, right, his distribution is always getting closer to the, that 70s and 80s. That is also fine. What he found, right? He found out in a particular year, there is not a single student who scored 34 marks out of 100 in any subject. There are marks like that. There is no student who scored 89. There are very few students, who scored 61. There are no students who scored 79. So there are certain numbers which are missing. So what CBSE was doing? Whoever is getting 34, they're adding 1 or 2 marks and passing them. The pass rate बढ़ रहा है ना? And whoever is getting 89, they're putting 1 mark and making them 90. So 90%, more than 90% people are increasing. So CBSE is actually goofing up the data. They're cooking the data. They're adding numbers and subtracting numbers to make the data look good. So yeah, statistically you can prove CBSE is goofing up, but then again, they'll not accept as usual. Anyway, so this point is what? Hope you guys remember. V probable. Did you guys do this in chemistry? Maxwell distribution. This is your V probable. We'll write down anyways. What is this? Then you have something here, V mean. And then we have something here, VRMS. So what is the area under the graph? So if you look at the area under the graph, which is integral NV dV, which is integral dN by dV dV, which is integral dN. So if you add all this, you'll get the total number of molecules. So the area under the graph is the total number of molecules. Now let's talk about this velocities. So first thing is your V probable. So V probable is simply the velocity possessed by the maximum number of molecules. You will get this thing by finding the maximum value of the function. You can do maximum minimum if the curve is given and you'll get it from there. What does V mean? This is your average speed. So how do we calculate this thing? So for particles, V mean is simply V1 plus V2 plus so on till Vn ben. Focus everyone, sit straight. Why are you guys so tired today? For continuous distribution, V mean will be integral V dN by integral dN. There you should know this integral forms and your particle thing. These are the formulas for when you have velocities for particles and you have a continuous distribution. Clear with this? VRMS is an interesting one. What is VRMS? This is the root mean square speed. This actually talks about the kinetic energy of the system. So this is the speed if possessed by all the molecules, you have the same kinetic energy as the system. Now, why do we need to define so many different velocities? Because the average velocity is 0, you didn't get any information, right? So we defined 3 velocities for 3 reasons. One, in chemistry, right? Think of like this. Where a nitrogen molecule and a hydrogen molecule collide at a particular speed of 300 meters per second, hydrogen will stick and this will lead to a formation of ammonia. Now you tell me, for the gas, this 300 meters per second should be what speed? If you want to find maximum amount of ammonia, shouldn't maximum number of molecules have 300 meters per second? So most probable speed is important for chemistry perspective. If you look at V mean, that tells you the average speed distance traveled by the molecules, whereas RMS will tell you about the energy. So how do we get that? Let's say we have molecules M going with V1, going with V2, going with V3, going with V4, and so on till Vn. So what you're trying to do, you're trying to replace this with all molecules going with the same speed Vrms. So we are trying to find a particular speed such that if every molecule had that same speed, then the energy would still remain same. So the energy of the system half m v1 square, v2 square, so on till vn square is equal to half into nm vrms square. So we get vrms will be root over sigma vi square by n. Check. And look at the name also. Root means square. Matlab velocities ka square. I can write it down here. v1 square, v2 square. So square of the velocities, uska mean average, uska root. Root means square. So it is an average value of the square of the velocities and uska root. Clear with this? Now how do we calculate this again? For particles, VRMs will be root over sigma Vi square by n. For continuous distribution, VRMS will be root over sigma V square dn by integral dn. There, you should know this stuff. We're going to do questions based on this in the next class. The integral form. Here. Now for the Maxwell distribution, now that function, for that particular function, when you try to actually derive the formula, these results also you should remember. V probable is root over 2 RT by molecular weight. V mean is root over 8 RT by pi into molecular weight. VRMS will be root over 3 RT by molecular weight. T is the temperature in Kelvin and molecular weight must be in kgs. For example, if helium is given, don't write 4, you should write 4 into 10 power minus 3. Molecular weight of hydrogen H2 is 2 into 10 power minus 3 kg per mole. You should not write 2 gram per mole. There. So this is another 3 formulas you should remember. So this is based on temperature. So this is actually how the velocities will vary. But later on we will see questions, where they'll give a hypothetical distribution. They will tell you if it is not Maxwell distribution but some hypothetical distribution, then how do you find the velocities? Yeah. So that's a bit of it. So next class when we catch up, we will continue on Friday again. Like I said, today there's a small session there. I need to be there. So we'll wrap up for today. So Thursday when we catch up, we'll continue from here. The chapter is almost done. There's not much left. After this, we will do something called, we'll do a few questions on this RMS. Then we'll do something on degrees of freedom. And then we have something called collision rate, free mean path and all that stuff, especially important for mains. Mostly should be done with that. And then we'll start off with the introduction for thermodynamics. So like I said, in the heat and thermo and heat transfer, those are the 2 major chapters. What we're doing so far is still kind of fine. So Okay, I think with that we'll wrap up for the day. So I'll see you guys again on Thursday. Thursday, as usual, we'll have it 8:30. We'll continue from then. So if you have any doubts, anything else, please stay back and ask, or else you're free to leave. I'll see you on Thursday. So take care, stay safe.